The overall goal of this method is to provide a simple, easy setup for measuring the evolution of hydrogen gas from a chemical reaction.
This method can help researchers in the field of hydrogen generation to measure the efficiency of specific catalysts and materials in generating hydrogen from reactions with aqueous solutions. The main advantages of this technique are that it is simple, low cost, and robust.
Before beginning the procedure, add water to a glass bowl until it is approximately 3/4 full. Then, place the bowl on a temperature-controlled stirrer hot plate set to 50 degrees Celsius. When the water reaches 50 degrees Celsius, place a 50 milliliter round-bottom flask containing 5 milliliters of deionized water into the bowl, such that the level of the water in the bowl is well above the level of the water in the flask. Set a thermometer into the neck of the flask to monitor the temperature. After equilibration, the temperature of the water in the flask is usually approximately 5 degrees Celsius lower than the set point on the hot plate. When the temperature of the water in the flask remains constant over a 10-minute period, fill a beaker with deionized water and place an empty beaker onto a data logging balance. Next, use a plastic sheet to construct a bridge for transferring water from the spout of the water beaker to the empty beaker on the data logging balance, taking care that the plastic bridge is not in physical contact with the beaker on the data logging balance. When the bridge is in place, fill a 500 milliliter measuring cylinder with deionized water and cover the opening of the cylinder with a gloved hand. Invert the cylinder and place it into the beaker of water such that the opening of the measuring cylinder is just below the surface of the water.